Question 58, graph the inequalities below on graph paper. So these are linear inequalities, and unlike our number line, these have two variables, right? We've got both an x and a y. And when we see that, right, we realize that like the case when we're graphing with a just a single variable one on a number line, this symbol indicates the boundary point. So right here, when I've got less than or equal to, this indicates that my boundary line is going to be solid, a solid boundary. Over here on B, right, this is not or equal to, this is just strictly greater than, so this is going to be a dashed boundary line. The difference being is that on the dashed boundary line, it means that that line itself does not contain solutions. Only the things in the region, in this case above the boundary, because this is written as y equals or y is greater than, the y's above the line will be solutions. Over here, the y's below the line, the opposite of x plus 5, or the line itself would be solutions. So these are pretty straightforward to graph, right? So we're just going to go ahead and graph this boundary, right? So we've got a y-intercept that's at 5, at positive 5, and we've got a slope that's basically negative 1. So I just go down 1 over 1. That's a point. This is a point. This is a point. This is a point. We get the idea. So we can grab our online ruler or digital ruler in OneNote. I'll just slide this over here, and then I'll just go ahead and, oh, I should have zoomed out first. I'm going to line that up again. And because this was less than or equal to, the boundary is included. So I'll go ahead and draw the boundary and turn off that. Well, I'll just leave it there for now. Now it's a matter of what parts of this get shaded, right? Now it says literally that the y's are going to be below this curve. It says the y values are less than or equal to that relationship, or that, yeah. So that means that if I was to plug 0, 0 into this would work. And if I do test this one point at the origin, 0, 0, this does become 0 is less than or equal to 5. So it's kind of nice to know that just like when we were testing on a number line, you can test, and here it turns out that this works. So my solution are all of these values, right, that are on the curve or below the curve. So I could shade all of these in. I don't want to get carried away, but every single point down below this curve is the solution, each xy pair. When you plug in x, when you put in y, it'll turn out that the y value on the left hand side will be less than the opposite of x plus 5 on the other side. All right, so let's do the same thing for part B. This relationship is strictly greater than, so we're not going to be using a solid line. We'll use a dashed line. But let's go ahead and draw the boundary curve again. So the slope is at the y-intercept rather is at -1, and my slope is positive 2/3. So I can come down here at -1, put my first dot, right? When x is 0, y is at -1, and then it's up 2 over 3 units, up 2 over 3 units. So you can see that pattern. I'll do one more, up 2 and then over 1, 2, 3 units. So that, right, is a very nice definition of my boundary. I'm going to line up the ruler as best I can. And then once I've got that lined up, instead of drawing the solid line this time, I'm going to draw a dash line that meets it. So I'm just going dash, 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 dash. And the difference is meaning that if I picked a point on this boundary, points on this boundary will not make the inequality true, because we're not talking about things being equal. We're talking about something being strictly, in this case, greater than. And yes, 0, 0 is above the line, so I could test that, and I predict that 0, 0 should make it true, because that's a y value that is above the boundary. So 0 is greater than -1 is true. So my solution would be not the boundary line, but everything on the xy plane that lives above this boundary line. And there they are, two different inequalities. One was less than or equal to, the other was greater than, strictly greater than. And we just graph the boundary lines as either a solid line or a dashed line, and we're pretty competent. And I think you're competent and confident in drawing those linear boundaries. And then either interpret it as it says the y's are below in the case of part A, below or equal to. In the case of B, y's are above. And also, if 0, 0 is available as a test point, it's also nice to get that confirmation of plugging in x is 0, y is 0, and making sure that it makes it either true, as it did in this case. If it made it false, then that would just be confirmation that I would be shading in on the opposite side. All right, so that's it for question number 58 in section 9.2.2.